我们确认一下。
No stress, no stress. Alright, everybody relax.
Relax.
Yeah.
Chill.
We will find out the regulation. Okay.
Yes. So my name is Alex, and so my topic is droplet microscope. And I'm from the team. You can't see me. And this is a problem statement by looking through a single water droplet placed on a glass surface, and it can actually observe the droplet act like an imaging system. And we want to investigate the magnification and the resolution of the lens. And first, we main focus on 2 points. The first point is how can the droplet microscope have the best magnification and the resolution. And the second point is how to control the shape of the droplet. And this is the phenomenon. Actually, the outside monocoats will be attracted by the inside monocoats. so there is no force that attract outside there. Outside there will be attracted by inside, so it will form like a spherical shape. And the basic rule of the convex lens is the Snell's rule. And because the light, when it passes through different material, it actually bends. So it can, like a imaging system that we can observe object and magnify it. And this is the lens maker's formula. And X stands for the focal point, R means the radius of the curvature, and the N is refractive index. And as for, there's R1. R1 means the shape of the top spherical of my droplet, and the R2 means the surface of the glass. But actually, in my experiment, we drop the droplet on the glass, so actually the curvature of the R2 will be 0. And we predict that the bigger the curvature is, the magnification will be also bigger. And here is the model setup. And this formula is that we infer to describe the shape of the droplet. And the delta P means the pressure difference between the droplet and the outside air. And the R squared pi means the bottom area, and the gamma means the surface tension, and the theta means the contact angle, and the 2 pi R means this, I don't know how to speak in English. And the delta P is proportional to sine theta. And as for, according to the Young's Laplace equation, the delta P will be proportional to the average curvature of the spherical. So we infer that the sine theta will be proportional to the h, which means the average curvature. And here's how we set up the convex lens. Actually, when you just put the drop into the glass, actually it's hard to control the radius and the volume. So we made a device. Then 2 plastic sheet, 1 plastic sheet with hole, another without, and we just drop the droplet inside and control the volume of it. So we can control that the radius, bottom radius is at 6 milliliters, and it's easy to control radius and the volume. And this is how we place. And this is actually an iPad, and each lattice is 0.05 centimeters. And this is our droplet microscope. And we can change the object distance by the letter and analyze the data. Next. And after we will take the picture from the side and from the above, the vertical above. Vertical above to analyze the magnification, comparing the inside and outside. And this each lattice is 0.05 centimeters, and use the image J to analyze curvature, magnification, and contact angle. And here is the resolution formula. R means the resolution, and 0.61 is a number in this formula. And lambda means the wavelength of light, and N means the refraction index, and the theta means this. And this is how the angle that shoot into the convex lens. So during the experiment, we made a serious problem which is called the spherical aberrations. Actually, a droplet, the outside focal point is different from the inside focal point. So we cannot observe the outside, we cannot observe the magnification outside because it's blurry. So we just analyze the curvature inside and magnification in the middle. This one, you can see there's less spherical aberrations. Experiment 1, we control the bottom radius, surface tension, and the thickness of the hole. As for the independent variable, we change the amount of the water and the object distance. As for the dependent variable, we want to analyze the curvature and the magnification. And this is the side picture of the droplet, and this is the above picture of the droplet. And here below are the water amount, which is the milliliters, and this is the curvature, is mu n. You can see yourself. The below line, the black dark line, is the middle curvature. As I just tell you, we only analyze the curvature in the middle because the outside will be the spherical aberrations, and the outside is the average curvature, the whole curvature. Next. This is the magnification, and below is the water amount, and this is the magnification. As I just mentioned, both magnification and the curvature increase along with the water amount. The water amount increased, the magnification and curvature also increased. So below this, the dark line is the object distance at 0.7 centimeters, and the red line means the object distance at 0.8 centimeters. And for the experiment 2, we have discovered that the water amount will have direction effect with the magnification and the curvature. So we want to find the biggest magnification. So we add some hydrophobic substance into our sheet with plastic hole. So as for the independent variable, we change the amount of the water. As for the dependent variable, we want to analyze the curvature, and the magnification will be also bigger than what is the maximum. And this is the side picture. And below is the above picture of my experiment. And as for the experiment, below the x-axis is the milliliters of the water amount, and this is the curvature. And as you can see, the water amount increased, and the curvature also increased along with the water amount. But the interest point is here. The biggest curvature is actually at 0.06 milliliters. And when it comes to 0.07, the curvature actually decreased. So it's not as higher curvature as the 0.06. And as for the magnification, also acts the same thing. When it is 0.03, they increase until the 0.06. The magnification stopped, and the 0.07 milliliters actually decreased. And the magnification, this is the magnification picture. So why is it? When the curvature decreased, actually the dotted line is called the droplet without gravity. So if we add the droplet without gravity, it actually form like this, and with the solid line means the droplet with gravity or bigger gravity. And it helps you directly know that why the curvature decreased. And the upper, the curvature actually bigger, and the curvature actually smaller. And for experiment 3, we want to know that is there proportional for our contact angle and average curvature. Average curvature, not the middle curvature, this is average curvature. So this is the curvature of the 0.2 to 0.5. And this is the previous one, we had the hydrophobic one, 0.3 to 0.7. As we just mentioned, that at 0.6 is the maximum, and the acceleration actually not higher as the previous, actually just like this. And this is the relationship of the contact angle and the average curvature. And below the x-axis is the sine of the contact angle, and the y-axis is the average curvature. So it's very high form to our prediction. So just like we predicted, the sine theta will be proportional to our edge curvature. And this is our resolution prediction. The wavelength of visible light is about 400 nanometers to 700 nanometers. So this is the wavelength of light, and this is the resolution minimum. So the definition of the resolution is that how small can you tell from the two lines. So when we you see the two lines into one line, that is the minimum of the resolution. So actually, wavelength of light, when it increases, the resolution gets worse. And the resolution minimum of the object distance, with the object distance increased, the black is the biggest object distance, and the blue one is the lowest object distance. So the biggest object distance has the lowest resolution. Next. So this is our conclusion. In experiment 1, we have concluded that the water amount is positive correlate with the magnification and the middle curvature. And experiment 2, the data show the curvature and magnification will be affected by gravity, so the biggest water amount dome has the best curvature and magnification. And as for the experiment 3, the contact angle is positive correlates with the water amount and the sign of the contact angle. It's proportional to the average curvature. And in the resolution prediction, we created that the longer the wavelength and the object distance are, the better the resolution is. And here's my report. Thank you for listening.
I would like to ask you, how do you control the thickness and amount of the water droplet?
Oh, we didn't control the thickness of the droplet. We only control the water amount of the droplet. We use the parameter, 就是称重。So in English, yes, you can know the weight and you can know the water amount.
So how do you calculate your curvature?
Curvature.
Yeah.
Actually, I just mentioned that actually there is an application called the image shape. And this one, it can analyze the curvature. And this is the curvature, and as you can see, the side is actually a little bit bigger.
But you say you didn't control the thickness, so your curvature will also change at each experiment.
You mean the curvature will change in my experiment?
Yeah.
Yeah.
Because you didn't control the thickness.
Because curvature is our independent variables. So we want to change the curvature. So we want to get the best resolution and the magnification.
So you think the droplet won't be like this, like
Expand, right?
yeah.
Yeah, in the normal situation where we don't put a hole in it, it actually expand. And in our experiment, we actually add a hole to control the radius of the droplet, so it won't expand, but form as into the bottom radius.
Okay, I see. KGHS, and I'm upon the list here. This is our problem statement. And this is reporter's pros and cons. Reporter pros is he expressed well, and he understands statement well, and he used chart to explain the results. And cons, the procedure of experiments isn't clear, and he doesn't consider about the error bar. Although he used the tools to find it, but I think it also has some error bar. And this is our overview. Theory. He used some proofs like this and formula, and Young's place this one, and he used resolution formula, and his variable amount of water and the distance of object. And this is his conclusion. Water amount increase, temperature increase. Water amount increase, temperature increase only before 0.07 millimeter. And resolution prediction 400 to 700 nanometer. And I will invite the reporter to discuss with me. And the first one, I would like to ask you use this picture and which light you use, which color of lights you use.
You mean you want to ask
The color of
Yeah.
light.
actually the dark, because I analyzed that the dark has no light. You see that this is the actually every 8 pixels. This is not. This is, I just want to know. Let you guys know what is the spherical aberration. So this is actually the pixels of the iPad,
So,
and this is dark has no light.
so how do you calculate the resolution?
Resolution.
Yeah, because you don't have light, you couldn't calculate the resolution, right?
Yeah.
Yeah.
So how do I calculate the resolution?
Yeah.
This is the formula, and we just I'll take it clear. This one, this is the object distance.
Yeah.
Yeah, we know the object distance. Yeah, right.
Yeah.
Then we know the height of our droplet, right?
Yeah.
And if we know both of this, then we can know this, right?
So.
Then we can know the sine theta, right?
Yeah.
Yeah.
But this all theory, not your
Yeah.
not your experience. So did you do the experience of resolution?
I would like to say I didn't do the resolution
Okay.
experiment.
Okay. And your resolution define is just this type, right? Define.
Yeah.
Yeah. And did you consider the aperture of droplets?
Aperture.
Yeah, aperture. Aperture.
What do you mean the aperture? I haven't heard the word.
Yeah, like
Can you use the blackboard?
there is the blackboard. Something like this. You see something in this one.
Yeah.
Aperture. Aperture. APERTUR. Something.
Aperture.
Yeah.
I can see something with aperture.
Yeah.
Is that the device that help me? So please.
So did you calculate?
Um, I don't know what it's like.
Okay, that's right. And your lambda
No.
wavelengths, and did you use the average or amount of lambda wavelengths?
Oh, two pages less.
Or
This one. Actually, I divide. You see the different wavelength of light.
but it's all your prediction. Did you do the
Yeah.
experience of this?
No.
And what is this amount? Did you have exactly amount of it?
Oh, this is the resolution minimum. And this is the resolution minimum means how short can you tell difference from two objects.
Oh, I see. And so you do the experience with no light, with no any light.
I only do prediction of the light, and this is the optical resolution. And according to the formula, this is the chart that I make to predict the resolution.
So you just did the experiment, like you consider about the curvature and anything else, right? Not the.
So you mean the curvature actually affect the shape,
Yeah.
the resolution?
Yeah.
No, I didn't consider.
Oh, okay, I see. And did you do the magnification experiment?
Yeah.
Something, yeah. Can you show me that?
Experiment. This one is the magnification.
And which magnification you use? Magnification you use is.
Oh, I see. You mean because my experiment, my object is like it's vertical to the light path, so it is the horizontally resolution, magnification. Sorry.
Oh, it's viewing angle or lateral magnification.
Yeah. Actually, we do the experiment. We always like direction, and we use vertically, like the 3 point, my eye, the cell phone, the droplet, and the object. There are 3 on a line, so it won't like there's no angle between my device.
Oh, this one we can back to our aperture.
Curvature.
No. And I draw this one. Yeah. Aperture.
Oh, we will discuss it later.
Yeah. And you use cell phone to look at the droplet.
Yes.
And did you know it has each intrusion it has something not regular, not rock, not circle as its edge.
Oh, I know.
Yeah.
But in my experiments, we actually the whole page is like this, but we only take a little and right in the middle. So the circle of the cell phone can be deleted because we only take the middle.
Define it because it's not almost the same in each liter like this. Your amount of water will cause different change like this, different diffraction like this.
So the problem, main point of your problem is that my cell phone maybe has a spherical operations.
Yeah.
So I didn't consider the spherical operations of myself.
Okay, I see. And can you explain the Okay. And no. Sorry. And may I say my opinion about aperture?
You can tell me what is the aperture means.
Like radius, and it has different. It has some distortion of its edge. So.
Chairman, can I use the blackboard? Can you use the blackboard to tell me what is the aperture means?
So it's a circle, and it has some shape. It has some like this or like this, right?
Yeah.
Yeah. And we should calculate it in our experience.
You mean the thickness of my droplet?
Yeah.
The thickness of my droplet. Actually, we set all the thickness of my droplet as experiment, we set all the aperture that we set for, we use all the same. So I don't think that is really affected to our resolution and magnification.
Okay, and this one,
Okay, this is a good point. I will consider that in my future.
Okay.
Thank you.
And this one, you say you didn't consider the resolution about the experience.
Yes.
And how do we measure the results of resolution is correct?
Actually, the formula is used by the global scientist, every scientist or student. All the studies use the formula. So I think the formula, if they don't have problems, they don't have problems.
Okay, and is this one a line, or it has some like this, or like just this, just like this, just like a line? Because your formula said it is just like a line. That has curvature.
It is a line. It is a line because the glass that I hold it is a line. It's a line. They don't have curvature.
Okay, and it will expand, right?
I have to explain
Yeah.
that in my next vector formula.
And could you tell me your stand up again?
So
Yeah.
this one.
Does the lines of your iPad affect the results?
Actually, I just mentioned that I take the black line, the dark line. The dark line has no light, so it won't affect the result of my experiment.
But your iPad only has some lights, but it will affect the results, right?
Yeah, we should consider that the different wavelength of light will affect. But in my experiment, I used a lot of lattice, and the lattice, each other, the dark line has no another aberration, which goes the color aberration, because the dark has no light, right? Do I work my point?
So your iPad lights could be ignored, right?
I didn't say my iPad light could be ignored. I just say the dark line has no light. So the dark line has no light, so it is not the main point of my experiment.
Okay. Did you consider the error bar of your experiment?
Oh, actually I didn't consider it, but I do have some. This is some. I do a lot of data, and this is the biggest, the highest, and the lowest. And this is the blue line stands for the average. So I take the average and use it as I didn't do it error bar.
Okay, and you do the experiment many times, and you draw this line and to take a median.
You mean the average curvature, right?
Yeah,
The average,
this
yes.
data. Okay. And did you consider another error to affect your experiment?
Another error?
Yeah.
What kind of error is that?
Like something like your lights or another water or.
So you mean I want to point out my mistake?
Did you have another mistake you have considered about? Okay. And thanks.
Okay, thank you.
And I want to summarize our discussion. First, I asked, did he use white lights or another lights? And he didn't do the experiments, and all the lights is what another said. And he just do the prediction about it. So, and he said he will do the experiment next time. And he didn't do the resolution defined because he doesn't do the resolution experiments about. Yeah. And
Okay, so here I would like to invite the reporter and opponent up to the stage. And first, I would like to ask the reporter about that. Do you think about that evaporation will be an important factor to this phenomenon?
Evaporation
Evaporation
of what?
of the droplets.
Of
Will
the
it?
chocolate.
Yes or no?
Yes, I think this
Okay,
is
and what about your? Yes. Okay, so next question. In the geometry, where did you get your curvature that is measured?
I use image.
I know you use imaging,
Yeah.
but where? What position?
Oh,
Like, here is a sphere. It's like
I just middle.
the middle of it. Okay, so next question will be that do the resolution have impact on the what? It's like the resolution has the impact on the water's shape.
The
Does that
resolution
have relationship. Yeah, the
Mm,
resolution and the shape of the water.
I think that we control the radius, right? So if I become
So
the radius.
yes or no?
Yes, yes.
And
because
how do you
this
opponent
one-
think?
I think yes, because the shape.
Okay. So for the reporter, do you use the auto focus of your camera or you manual to design your photo?
Focal point.
Yeah.
Yeah, actually the focal
You
point
do it by manual or auto? Thank you.
total.
Auto.
Also on no.
Okay. So what about? Do you think that the image that you presented there is a real image or a virtual image?
It's definitely a virtual image.
Okay. And how do you think about it?
I oppose.
Okay, so well, as your, do you believe that your droplet will be having a perfect spherical shape that like there? Is that a perfect spherical shape?
Give me the
Yes or no, please.
公式.
No.
No, it's not.
No, it's not. Okay, so do you believe that the iPad screen will affect your experimental results? That a component of your iPad screen?
What kind of?
The components of like other parameters will that affect, in your opinion?
I think it's the basic one. I only consider the basic one.
Okay, what do you think about will it?
I don't have something about.
I want to answer again. Actually, I control the humidity and the temperature. I use the two wire.
So next question: will the volume and the shape have the relationship between the water's volume and the shape of it?
Before this, it has a relationship.
Okay,
Yes.
and what do you think?
It has.
Okay, that's all of my questions. Thank you. Honorable juries and fellow competitors, I'm a reviewer from King Alpha Tsinghua High School, and today I'm going to review problem number 2, droplet microscope. And for summary of the report, their experimental part, they make tiny hole to measure the volume. They also capture the photo from top and side. And they do variables such as the water's amount and also surface substance and also contact angle. And for theoretical parts, they use dense matter equation, Young's-Laplace equation for H, and also they use Snell equation. And for reporters' performance, that we believe that they have clear delivery and they also have clear pictures for the experiments, and they also have good setup for radius control. And for weak points, that they can do more investigation of experiments for various parameters, just as the opponent just asked. And for summary of the opposition, is that they, in the experimental parts, they have asked about light color, and theoretical parts, they discuss about the resolution calculation, and also curvature that is discussed, and also the wavelength usage, and which is also discussed. For the opponent's performance, that we believe that strong points are they point out the lack of experiments for the reporter, like the parameters, and they also giving their own opinion. And for the weak points, that they didn't discuss complete for the problem that they asked. And for this discussion part, the first opponent asks how the resolution is, and the reporter's response is no experiments. And for our own opinion, that we agree with the opponent for the examination for the resolution. And for another discussion, that's for the curvature and resolution relation, that the reporter doesn't think that affects, and we agree with the reporter that there is no relationship in it. And for reporter's portion, that we first asked about the evaporation's impact, and for reporter and opponent both states that it will. And for our own opinion, that if it's not it's a short period of time, that it shouldn't be mattered if the experiment is done in a short period. So, and the next one is that where did you get for the curvature? The reporter's response is in the middle, and we believe that the position will affect, and it should be measured in the middle that is used for their experiments. And for the question that about the resolution relation to the parameter of the droplets, that they believe it will pose effects. And for our own opinion, I believe that for the formula reporter used is the optical resolution, and it's opposite from his experiments, which is the image resolution that he measured, and represents which the optical resolution represents the wavelength change, and it's not impact. And for the autofocus or manual, they use manual, and we agree with them that it should be used. And for real image and virtual image, that they answer for, reporter answer for the virtual, and opponent also thinks it's virtual, and we think, yeah, it's also the virtual image for a photo that is shot. And for about the droplets will be a perfect sphere, that reporter doesn't think so, and for our own opinion, that's in page 11, that it is not, and the formula is for the limitation value in the page 7, that they should be considered the formula is not for their experiments, and because it's the limitation value. And for another question, that for the volume and the shapes relation, the reporter responds yes, there is, and opponent also thinks so. And we don't think that there is such a relationship, and it depends on the internal pressure that is formed back in the droplets. And that's all of my review. Thanks for your kind attention.
So they gave me some opinion. For example, the opponent gave me the opinion about my resolution. I think we must do some experiments to prove our resolution is right. And as for the reviewer, they ask about the image is real or is virtual or real, and it's actually virtual. So I should say it before. And as for the spherical aberrations, I think it's more. I think we should consider the middle one, because the middle one has the less spherical aberration. And as for the focus of the focal point of the phone, we should use the manual focal to control the focal point of the phone, and we should not use the auto focal. And as for actually the thickness is not the thickness of the droplet. This is the thickness of the hole, and that will be my conclusion.
Open questions to the jury. Any questions from the jury?
The bump radius won't like spread because we don't use the bump radius. We will change two dependent variable in the same time, and I don't think that is a good experiment.
Other questions from you?
No dash 15. So, just wondering, the outside of the droplets, it looks like the size is bigger than the center.
Yeah. Because the outside, the focal point of the outside is actually shorter, so that the magnification will be bigger. So we didn't consider the outside because the focal point of the outside and inside is different. So we won't consider the outside. But outside is real, it's actually bigger. All right.
I mean, the edge,
Yeah, the edge.
no, outside of that.
This
The outside of the droplets.
outside of the chocolate.
Right. Very
This is not this is not the iPad lattice. Actually, this is we first put some lattice on it to make sure the rate, but actually that didn't work. So that is we should like erase it all.
Questions?
Question for the opponent and reviewer. So, what do you guys about the definition of resolution and the report that ends the latest compute the serial domain? So, what's your suggestion for measuring the resolution experimentally?
Okay, I think we should do resolution experiment next time because resolution is the proper statement span focus.
So how do you do that? How do you measure that experimentally? Can you use
Oh, I can use the one color lights to do it, and we can hang the droplets up on something. We can use something like this to hang the droplets, and we can use the camera to see the resolution of our droplets.
and for the reviewer?
For reviewer, we think that it's a optical probit statement just asked, and so it should be calculated for the optical resolution. And for the optical resolution, we'll choose to use a source light, which is in the color of certain wavelengths, and we'll measure it and have pictures from another side for using some image like the image stage2 software that can use to detect the wavelengths that is outputted. And in this way, we can determine the resolution of this droplet.
Thank you.
Thank you.
Other questions? I want to ask the reporter.
Yes.
So how do you define the magnification?
Magnification. Magnification is actually the optical,
Yeah. How do you define it in your
the height of the optical.
your measure? How do you measure?
How do I measure? And this one is the picture. So the middle one is the edge lattice, and after it magnified, we will compare two of them.
Two of them compare what?
Compare the length,
The
the length of it.
the area or the
Mm,
length?
The length, the height, because the definition of magnification is the height of the height rate. So the one in a chocolate divided by the one on the outside. And I use the image J to use image J to calculate, but this is not the one. I use image J to calculate the magnification.
So, jury, please compare our scores. score for reporter. 6, 7, 6, 6, 5. Let's go for opponent. 5, 7, 6, 7, 6. Let's go for reviewer. 7, 8, 7, 8, 5. Thank you for all the teams. Let's take another 10 minutes break.